Yeah, are you just changing the slide because you are not audible?
Is the screen changing right now? Still the same issue?
It's changing now.
Okay, just a minute. Tell me, is it changing now?
Yeah, it's changing.
Okay, 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 okay. So, in order to test the intelligence, they have created a simple framework. Okay, so that framework is divided into few categories. Okay, so one is thinking humanly, thinking rationally, acting humanly, and acting rationally. So these four categories will fall into AI, which try to see how an AI system is trying to behave in terms of intelligence. So what is first one, right? Thinking humanly. So what is like human like? Okay. So what is human like? We able to work on a given task. We able to achieve a given goal, right? It may be any goal. Whenever you wake up in the morning, you just go and brush and then have your breakfast, start going for your office, and then after going to office, there will be a set of problems given to you. It may be any problem, right? So those things will be in the same in the manner of puzzles. I can say games. I can say if your intelligence level or if you have the knowledge you possess to solve those problems, you will be having those problems to be solved in a given time easily. So then the cost you take or the time you take to complete or the path you will take to achieve your goal will be very less and you will be completing the given set of tasks as an agent, AI agent. So in terms of human like we simulate intellect and behave as a machine. Okay, we simulate intellect and behave as a machine. So whatever we do, those tasks are being now replicated with the machines. It may be driving a car, cutting vegetables, cooking, right? And then in factories, the automation or the robots can able to stitch the clothes. They're able to cut and stitch. There are number of tasks which how the human stimulates and behaves to do a task. We are trying to replicate it with a machine. So similarly, common sense, reasoning, experts such as lawyers, engineers, doctors, any number of professions can be indulged into this AI or within can be built using these AI systems and social behavior. Yeah. So this is something very different to include in artificial or AI systems which can also mimic or behave like humans when they are with other humans or other robots. Next, rational like. So rationality is nothing but is something I can say you will be able to realize where exactly you are. You're able to measure yourself. So rationality, I can say, is also a property of thinking or intuition, human intuition or the AI intuition, which replicates itself from other non-intelligence being. Okay, so we have human not about humans, but every living organism, they have a brains. They have certain level of intelligence. Compared to that, humans are very high scored in their intelligence score and performance, right? They're able to do multiple set of tasks and they're able to build a lot of stuff around their environment compared to the other animals. Okay, so rationality is something which makes humans different. And thought process, yeah, thought process is like whatever humans thought, they create set of rules, they build a lot of gadgets or applications or ideas, right? So with the human intuition, the reality of many of the things came into existence, initially with ideation, then as testing and prototype building. So behavior is something which takes the consideration of environment. You will be behaving differently at home, at office, and at outside with friends, right? So study of how to make computers to do things at which in the moment people are better. So similarly, how you can able to build this intelligent system to behave similar kind with human. So Turing test is something which tries to test the intelligence of a machine. Okay, if a new machine such as recently we came to know, right? OpenAI's GPT-4 or GPT-5 is AGI. It passed the test of AGI, right? So in order to test that, there will be a set of conditions, there will be a set of curated tests will be there. So that the machine or the AI system will behave like a real actual human. So you can see here, there is one person, there is a one woman who is working on the typewriter, and there is inside an interrogator who is measuring the work done by human and the computer in the other way. Is the screen visible to you?
Yeah, it's
Yes,
visible.
it is.
Yeah. You can see that if the interrogator says both the work done by a human, okay, then he able to judge the computer as a human. He don't know the other end the computer is being or the robot is working from the other end. He only knows that the person is working and there are two persons are working. He judges both of them as the humans. This if this integrator or this robot or this computer pass the test with this uh, interrogator, so this machine will be called as an intelligent machine. So if a AI system bluffs human and pass and mimics itself as a real human, then those systems will be called as intelligent machines. So you can see computer. So what is happening? Natural language. So both are working on the language. So typing and the interrogator seeing the work of the human and the AI system. And the knowledge representation, how well they are expressing their work, reasoning, everything will be incorporated while building this test. You can see here again how AI has been emerging from past 70 plus years. First, it's started basically with language generation, natural language generation. So they build initial tokenizations, try to understand and transfer the information and machine translation basically. So that actually started in the beginning and slowly it takes into many shapes with time. And this machine translation also developed and matured into natural language processing. And we have other concepts of AI such as uh, knowledge representation, reasoning, machine learning, and then slowly we got into problem solving related to humans thinking humanly, logics and problem solving, then AI agents acting rationally. Here are few examples of AI which able to replicate common sense reasoning, and it able to do the reasoning with the help of probabilistic one, right? And also it depends on the environment, goals, set of nodes, search, right? So it able to optimize its search, and there are many things, there are many problems to be solved, there are many games, gamification, planning, everything will be have been worked on with onto the AI problems. Similarly, how they have worked on with different applications on they build with time. Okay, okay, okay. So this is the emergence of AI, which started initially in 1950s, and then slowly it developed further to replicate actual human brain and build human consciousness. But after some time, they're not able to achieve it, and some kind of AI winter came up where they stopped the AI research completely, paused for some time, and there was no funding. They thought of AI is gonna die soon. And slowly in 1986, with the emergence of neural networks, backpropagation, and other models, which really helped this field to accelerate the development, and with the availability of data, compute power, and this technology is being accelerated every year. You can see here, so yeah, 1943, so basic logic design was being built. Then Turing test came into picture. And you can see here, adoption of AI started with multiple people. Seminars came up, people try to present their ideas, research papers. Slowly, discoveries of neural networks started. They built some kind of what I can say perfect perfect machine, which able to expert system I can say. So which is something we can now called as React system, right? So earlier there was some kind of expert systems which are good at certain domains, which are able to, and also in the future they are trying to replicate those expert system into a full-fledged human intelligence replicated uh, body or AI system. Okay, okay. And yeah, I said implementation, research papers, everything has been started. And then again, with the advance of data, has said, right, uh, the computer vision has gone into more development. And then with LLMs, we started able to utilize multiple set of tasks, we able to utilize this single LLM model for NLP tasks. Now, we just again try to walk through with agents. What are agents and why for every agents an environment is very important. What is rationality and the performance and environment and how these are all connecting with agents. A simple term I can say agent is like a human being, which is who is on earth. Okay, he can do any task. He may be a doctor, driver, carpenter, right, cleaner, anyone. I can say take all the humans on the planet as an agent. And what is the environment around the agent is the earth, the nature, right? It may be climatic condition, it may be their houses, the footpaths, everything that is being created, that is can be called as environment. What actually agent can possess? If an agent use his car to drive on the road, so that is his uh, that car is actually accelerating his performance, and so has said right there will be a goal, and he's trying to reach the goal using those set of what I can say tools. Multiple tools existed around. I can say car is also a tool. Uh, any kind of house is also a performance tool. So now we can go with what are different environments and agent types. So agent is something that can be viewed as who are able to perceive its environment. Has said human able to perceive its environment, and he has few senses, right? We have six senses. You're able to perceive and feel the ground, the air. You're able to taste the food. So you feel be like you are alive, and there is something surrounds you. As said, human agent, eyes, ears, and organs and other sensors, hands, leg, mouse, or actuators. Similarly, with robotic agents, camera and sensors are those sensors to pursue the environment. Motors for the movement of moving forward and backward. Those are actuators uh, to to follow a set of path into the environment. So we are now evaluating the agents, environment, agents, actuators, and it's how is behaving in real time. So now see what is an agent. Agent has few legs, right? Few hands. He has a brain. Okay, so he has something in his mind. So it may be a task or anything. So in order to complete the given set of tasks, he will be performing where he will be performing those set of tasks in the environment. Environment is where the agent will start working, utilizing it, showcasing himself, what he is actually. So what he actually do? He actuates actions, percepts, understand the environment and the given set of states, task, and see the goal is completed or not within the environment. So agent function maps from perceive. Perception is nothing but a set of given knowledge to action. So we will be having possessed knowledge. Those knowledge will be converted into actions. So where it's being converted into the environment. And again he learn back some knowledge from the environment. He changes his actions. So this agent also being able to reprogram his architecture, okay, or this architecture is inbuilt and part of the agent program. So completely we can say agent is equal to architecture plus program. So what is this architecture? It consists of like environment, actions, perceptions, and his program. Now consider you have a cleaning robot at home. Okay, so you have two rooms in the home, room one and room two. In the room one, there is some dust, and you just leave your robot. It started cleaning. In order to clean, it just moved left, right, sucked the dust, and if it's complete, it need to stop the operation. Yes, who is this? Any questions till now? Okay. So what is a rational agent? Okay, so that is what we discussed about previously, an agent and environment. Here we are explained a vacuum cleaner. The agent is a robot and the environment is its room, and the task is to clean the room and clean the dust. So he need to be doing set of tasks there. So now coming up with rational agents. Rational agents will do the right thing and it able to perceive, understand and takes its action. So these rational agents take most of the time successful task. It able to perform better. It able to excel in every given task. So performance measure of a vacuum cleaner agent could be amount of dirt. So when compared with the vacuum cleaner agent, so you measure the performance of it is how much dirt it cleaned in a given room, how much time it took, electricity consumed. So those are the measurement for the performance of this given agent. And then how to maximize this performance with the given evidence. As said, the second room we have the dust, right? It need to clean up, but it has not cleaned up. It does not pursue the other environment. It is being only enclosed in one environment. So what is involved in intelligence of these agents? So these agents able to see the world, right? What is environment? To able to see the world, it should have some kind of vision. It should able to talk with the environment if its purpose is with interaction with human. So in order to act, speech recognition is something, and then the action has said actuates. You need to actuate those actions to convert. So the like the human being went to a coffee shop. There is an AI robot is being there, or AI machine is being there, which is serving the coffee. So the human said coffee, and it recognizes speech, and he sees the human who is exactly it is, and is trying to show gestures and replicate human appearance there, and then it start taking the actions with a machine to fill the coffee in a coffee cup and serve directly with robotic hands with actuators to the human. Okay, so this complete set of being replicated has the same as a real human being. How we are trying to replicate this? We need few things to be incorporated while building the agents. So it should be having knowledge of the given task. Reasoning is not required, but planning. So where exactly the human position might be changing in real time, he or the robot should see the real time position of the human and serve the coffee right away in real time by not only placing it a normal custom position, and learning adaptation continuously being updated as this is happening with all LLMs models and GPTs. I'm audible? Yes, if any questions, you can just stop me anytime. We have many other examples of this agent type and architecture, such as medical diagnosis, satellite imaging, part picking robot, interactive English tutor, so on, cooking, taxi driver. So again, we have the given example of the vacuum cleaner agent. We have the environment which need to be pursued. So that is the location and the content, which is the dirt, and left right movements, that is the action, circ, action, everything are action within the environment. So this is a set of actions to be taken by this agent, and this can be replicated with a programming part also, writing a function to take a set of actions. If there is no dirt, or if there is dirt, circ, change the location, right, left, so on. So what you are actually monitoring for these agents in the given environment, we are measuring performance and agents performance, agents environment, actuators and all. So performance is defined as reaching or utilizing the given task perfectly and reaching high value. As said, right, safety, destination, given final goal to be reached, profits. So what all the given task should have been completed 100%. Environment has a normal environment which similar to which replicates the human. Actuators which will be performed movements for accelerating the movements and all. Sensors which senses the given data from the environment. So these sensors may be video or image or audio recognition, speak recognition, performing the given task, right? Performing the location, uh, positioning the location. So this set of agents will be utilized for different set of tasks and different environments. So they might be deterministic, static environment or dynamic environment. So environment, there are multiple environments exist. So for each and every set of environment, there is a set of agent will be utilized. So these are the basic types of agents. Reflex agent, which performs the given set of actions on the given at a fixed location. Reflex agent with states, which able to change its state, such as car. So car able to perform actions. Also, it's moving, changing its path and state in the given environment. So for the car also there is a initial point and final destination when compared to the driverless cars, right? So utility is something which is given to the cost functions and the path which it utilized. So there might be multiple paths to for the given task to be completed in the space. So utility is something very important to have some optimization or minimization of the path to have a better utility to predict the path in reality while moving forward, so that there will be unwanted paths or unwanted cost can be reduced. Okay, simple reflex is car. If car in front is braking, then initiate braking. So reflex agent is something like braking system for the car. So if you build an agent or AI system using only breaking the given or giving only performing a single task or a given set of tasks, right? So that is something is reflex agent. And then goal based agent. So the goal based agent is also performing braking. Along with that, it able to plan and search and have a better utility. So finally concluding with AI agent, few of the characteristics such as modeling human intelligence, such as thinking, actions in space and acting in space, thinking rationally, acting rationally, history of AI, how you can build a rational agent, how the research of AI started and where it's exactly moving ahead. So this is the starting introduction which I have been going through. Any questions till now? Okay, okay. So yeah, moving forward with few of the topics such as search, planning, knowledge. Okay, I will just have a simple glimpse here. So within the search, we have many different algorithms such as depth first search, breadth first search, heuristic search. So this search algorithms usually performed in usual usually utilized to find the given solution. Okay, so which is hidden, and they try to follow a search path. It's like you want to go a certain given location. You do not know the actual path is all about. Okay, so with depth first search, it's like it's trying to utilize all its uh, spots in the given path, or it yeah, it will explore all its given path to explore the final goal. So exploring more paths will happen in depth first search, and also similar to uh, breadth first search, where both are similar, but one takes horizontal approach and other take vertical approach, where they exhaust all the given paths and take a lot of time to uh, exploring and reaching the final goal post. So compared to heuristics and A-star algorithm, where they try to also store the memory of their state in the real time in terms of x-axis or y-axis or GPS location. So whenever it's moving forward, it's also remember its previous steps, and also see how much time it takes to, or how many number of steps to be reached, to be completed to reach the goal. So within the search algorithm, we have two sets of search. One is informed search, and other one is uninformed search. So in uninformed search, without any or blindly it follows the path, but it takes a lot of time. In informed search, you will take the information and decide where you need to move ahead. So informed search is a better algorithm, and it's also a cost saving one. Utility function will be less. So now coming to knowledge representation and reasoning in AI. So which usually happens with, as discussed earlier, with rationality about environment, understanding and describing the world consciously, and generating a piece of knowledge, has said. So this knowledge representation and happen in the real world with uncertainties. So these systems should be dealing with uncertainties, probabilistic reasoning, questions answered. So they need to concisely build the given knowledge for any given set of tasks. So the knowledge also divided into two sets, declarative and procedural. So in procedural, you see you have already all the concepts built up, such as in NLP, embeddings, vectors, all is being utilized to build this solution. So similarly, with planning has said, right? So the planning is being built to achieve the given goal for the agent in the space, and it will be performing a set of actions and reaching the final destination or the goal post. Okay, similarly with learning, etc. Now we'll show a sample code. You can just go through it. I will have a walkthrough on it. Am I audible?
Yeah, you're audible.
Is the screen visible? Hello?
Yeah, it's visible.
Okay, okay, okay. So you can see the VS Code, right? So there is a Python code where for the given set of search algorithms, this Python code or the set of agent we build, it's a normal rule-based agent, I can say. So the rule-based agent we build, it's for depth first search and breadth first search. So where its part is, its job is to reach the final goal. It's while moving with set of states and performing and following the path. You can see here a node is created. So node I can say is the path which is created node class. So the state, the parent, and the action being attached to the node. Whenever the agent moves forward or it takes any path, any step, so those will be appended and also those nodes being added up. You can see add the number of nodes. And also we have created here for the given set of agent states, how many states to reach the final destination or frontier or goal. So what is the task we have given? This agent is following a maze. It may be any maze where this agent needs to follow the maze, and within this maze there is a final goal. It can exit from the given maze. So there is a entrance and there is an exit. So it need to find out the exit from the given maze. And also there is a width and height of the maze. which it took consideration, and whenever it moves forward, it validates the start position and the goal or the final goal of this maze or exit. You can see here before that, so it's not about, okay. So this is not about the complete depth first search and breadth first search. It's a normal agent which tries to exit from the maze. Okay, so I can show you. So this is the actual maze, okay, given to the agent. So this is the A, its starting path, starting node, and this is the B frontier. It needs to be reached there. So it took this path to reach the final uh, exit. Okay. Similarly, so in order to reach the frontier or the goal, it has been exploring 11 number of states in the process. So what are those states? This stars has been represented as the states to reach A to from A point to B. So this agent has been moving forward from A point to B. So similarly, any kind of maze you can create, and this is one search algorithm. So this is a simple search algorithm where this agent explored the exit of the maze, and it has been explored 11 number of states. So I am not going in detail today all this coding part. Tomorrow we can go in depth of the complete code of search and all the agents. Any more questions? Hello.